Welcome to lesson 11.3. In this lesson, we're going to build on something we introduced in 11.2 a little more. In 11.2, we briefly talked about the bell-shaped curve, also called the normal curve or the normal distribution. A normal distribution is any time your data has this bell shape. And a lot of data tends to have this shape. For example, height. Most people are kind of an average height, but you have some people that are really tall and some people who are really short. ACT scores. Most ACT scores are kind of this average score, but you have some ACT scores that are really high and some that are really low. You can even go so far as popping popcorn. Most popcorn kernels pop at the same time. Some pop a lot sooner and some pop a lot later. A lot of data in the world is shaped like this. And because it happens so often, we want to make sure to specifically talk about it. And once again, it's this normal distribution. So let's start by talking about some key features of what the normal distribution looks like. First off, it is symmetrical. And you can see that right here in this picture. The left side looks like the right side. It is always symmetrical. If it's not symmetrical, so it's shaped like that, or like that, that's a skewed graph, a left and right skew, which we also talked about briefly in 11.2. Next, it has one peak in the middle, and it's always one peak. If it has more than one peak, like that, that would be what we would call a bimodal graph. But normal distribution is not bimodal. It is singular modal. Next, the mean, median, and mode all meet at the peak. So right here at this peak, that is where the mean, the median, and the mode all are. And they're all right there at the peak. If the mean and the median are different from each other, that's where we start to get skewed data. Okay, next, the bottom axis is what you are measuring. The side axis is frequency. So kind of like we had talked about with our bar graphs and histograms. This bottom axis is whatever you're measuring. It's time, it's whatever. And then this axis is how often that thing happens, which is why it happens a lot more in the middle, that one hump. Now, these are some important ones. This symbol right here is called mu, M-U, mu. It's a Greek letter, it's a lowercase m, and it always signifies the mean or the middle of the data. So anytime you see this symbol, that is the symbol for mean. Now, for standard deviation, we use this symbol. It is called sigma. It's a lowercase sigma. And that stands for the standard deviation, which talks about how spread out the data is. So if you have a really big standard deviation, that means your data is really spread out. If your standard deviation is really small, it means your data is really close and clumped together. And it gives you things like this versus like this. So this would be a small standard deviation because all the data is clumped really closely together. Where this is a really large standard deviation because it's all very spread out from each other. Okay, next, the area under the curve is 1 or 100% of the data. So if I added up all these percentages underneath, I would get 100% or all the data. Now, finally, this last one. This is a big one and will come up in your homework. Normal curves follow what's called the 68, 95, 99.5 rule. Let's talk about this a little bit. Let's look at this normal curve right here. We already talked about the middle is always the mean. So right here is the mean, or mu. As we go out from the middle, we measure how many standard deviations are out from the middle. So we would say this one is 1 standard deviation, and we would say it's plus 1 standard deviation. This one is plus 2 standard deviations. This one is plus 3 standard deviations. And the more standard deviations you are away from the mean, the more unusual the data. For example, the mean or the average IQ is 100. If I have an IQ score that is 4 standard deviations above the mean, or like 150, 160, that is an extremely unusual IQ score. That doesn't happen very often. Or we could go the other direction. We can also minus standard deviations. So minus 1 standard deviation, minus 2 standard deviations, minus 3 standard deviations. And once again, the farther away you are, the more unusual it is. So for example, let's talk height. Let's say the average height of women is 5'6". Well, if I have someone who's 4'2", way down here, that is an extremely unlikely height. It's extremely strange or extremely against what's average. And so that might be like 4 standard deviations from the mean because it's unlikely. So that's where this curve comes from. The higher your standard deviations, the more unlikely it is to happen. So when we start to look at these standard deviations, this is where the 68, 95, 99.5 rule comes in. This rule says that if I go 1 standard deviation away from the mean, so 1 above and 1 below, that contains 68% of my data. So most of the data is within 1 standard deviation from the mean. So if you're less than 1 standard deviation from the mean, that's pretty average. It's pretty normal. If we go 2 standard deviations from the mean, that's going to hold 95% of my data. And it's holding more because I'm going more standard deviations away. I'm including more of the data. So I've now got this 95% going. And I can go even more. If I go 3 standard deviations from the mean, that has 99.5% of my data, which is almost all of it. So that kind of shows you once again, having something 4 standard deviations from the mean is extremely unusual because 3 standard deviations from the mean is almost 100%. So the farther away from the mean you go, the more unusual the data is. So that's the 68, 95, 99.5 rule. So that helps you see what percent of the data is included from this number to this number. And we'll go through examples of that in the problems that we're going to do. So one last thing I want to talk about right here that I had kind of mentioned, we can have skewed data. This is positively skewed, or we've called it right skewed. This is negatively skewed or left skewed. And those come from last time's lesson as well. So that is an introduction to what the normal curve is. In the next video, we'll dive into this idea a little bit more.